Welcome to this course on 8085 microprocessor. You will be studying this course in Unit 4 of the paper Signals and Digital Electronics. The paper number is EL3502 and the title of this unit is Microprocessor Part 1. You will be studying about Microprocessor Part 2 in SEM 4. In your previous semester, you had studied about resistors, diodes, capacitors and transistors. We have also studied about circuits made using these basic components. These circuits performed a specific task, maybe to amplify a signal, to filter a signal, to do addition, to do subtraction, to check for parities, but a specific task was performed by a specific circuit. Now many commonly used such circuits were made available in a ready-made form in integrated circuit in ICs. So you have an IC which was there for a specific purpose only. So for example, you have a decoder IC, you have an encoder IC, you have logic gates ICs, ICs of AND gate, NOR gate, OR gate. Then in 1969, Ted Hoff, an Intel engineer, for the first time designed a general purpose IC. The background for this was a contract which Intel got from a Japanese company to design a programmable calculator. Now the design necessitated 12 different ICs. But this engineer, instead of using 12 different ICs, used only one IC to do the 12 different functions based on the input given by the user. And this was the precursor to the microprocessor. And in 1971, the first microprocessor was released by Intel. It was known as 4004. And the term microprocessor was coined by Intel. Intel invented the word microprocessor. It was a 4-bit microprocessor. What do you mean by a 4-bit microprocessor? Now, as you know that microprocessor is a digital device, so the input of a microprocessor is given in a string of zeros and ones. And this string is of a definite length. For a 4-bit microprocessor, the length of this string is 4. So that's why it is called a 4-bit microprocessor. After 4 bit, 8 bits microprocessor, 16 bits, 32 bits and finally 64 bit microprocessors are now available in the market. But in our course we shall be studying an 8 bit microprocessor and not 64 bit. You may have a question that since the latest processor is of 64 bit, why don't we study a 64 bit microprocessor and not an 8-bit microprocessor? There are twofold reasons for this. One is the pedagogical reason. Pedagogical means teaching methodology. And the second reason is the industry usage. First, let us look at the pedagogical reason. It will be very difficult to study a 64-bit microprocessor initially because they have a very complex architecture and a large instruction set. And whether it is an 8-bit microprocessor or a 64-bit microprocessor, the basic concepts are the same. So once you understand an 8-bit microprocessor, you can on your own study an 16-bit, 32-bit and 64-bit microprocessor. It's just simple upscaling. Another reason for the usage of an 8-bit microprocessor in this course is the market share. 8-bit microprocessors are the most used microprocessors in the world. 64-bit microprocessors are generally used in some computers and few other high demanding applications, whereas an 8-bit microprocessor is used in a variety of applications, be it manufacturing, office, machine control, process control, instrumentation, so on and so forth. Such applications or such systems are called embedded system. We call them embedded systems because the microprocessor is embedded inside the system. It is part of the system, so that's why we call it embedded system. Here we shall have a look at a video where we will see some machines, some applications which are controlled by a microprocessor. You will not be able to see the microprocessor here, but all the process which these machines are doing are done because of a microprocessor which are in it. So this is a manufacturing machine. The way it functions, the way it moves is controlled by a microprocessor which is part of this machine. This is an old printer. A microprocessor based system to stir the contents of the bottle, and a computer. Computers also have microprocessors, but they are of a higher bit. Microprocessor consists of two elements. One is the hardware and second is the software. And in order to understand a microprocessor well, we should understand both its hardware and software. By hardware, what do we mean? By hardware, we mean the physical structure of the microprocessor, the architecture of the microprocessor, what is inside the microprocessor. And by software, we mean the language which is used to program the microprocessor. In our case, we shall study the assembly language of 8085, and we shall use this language to program a 8085 microprocessor in a microprocessor kit, but this will be in the next year. In the present semester, we shall have an overview of 8085 microprocessor and study some aspects of its hardware. Now, what are the course objectives? It has 6 course objectives. The first one is to have an overview of a microprocessor based system and to explain the functions of each components of the system, that is the hardware. Then in the software we have machine language, assembly language and high level languages to understand the concepts of this. Then we will learn about the architecture of a microprocessor and how it operates. A microprocessor based system always uses a memory, so we will understand about the memory organization, memory map, how memory addresses are assigned and what are the types of memories. And lastly, we shall study about some logic devices which are interfaced with microprocessor, which are connected with microprocessor. So these are our course objectives for this course. The syllabus of Unit 4, 1.1 microprocessors, 1.2 instruction set and computer language, 3.1 microprocessor architecture and its operation, 3.2 memory, 3.5 logic devices and logic devices for interfacing. These numericals are article numbers of this book which we shall be using. Microprocessor architecture, programming and application with 8085, 5th edition. You could use 6th edition also, which is very similar to the 5th edition. Author is Ramesh Gaonkar, publisher is Pendram. This is an interesting subject, very simple. Understand the concepts and things will go very well. So wish you all the best and wishing you a very happy journey with 8085. Thank you.